Greetings, this is Ms. Jackson. Here is the page 133 extra practice. This page is reviewing how to compare fractions. Problem 1. Each fraction strip is one whole. That means this entire strip represents one whole something. One whole candy bar, one whole pizza, one whole swimming pool, one whole mile. Who knows what the whole is, but that's one whole thing. All the fraction strips are equal in length. Color one fractional unit in each strip. So let's do that first. Before I even color it, I like to have my students label every part of the fraction. So because the top one is broken down into 4 sections, the bottom number, which is the denominator, is going to be a 4. That represents how many total parts there are. The top number is going to be a 1 because each of those sections represents one part of that whole shape. On this one, we have 3 sections, therefore our denominator is a 3. And on the bottom, we just have 2 sections, therefore our denominator is 2. When we go to color one fractional unit in each strip, you need to make sure that you're starting and comparing units that are right beside each other, or right on top or below each other. So right here, I'm going to start with all the ones that begin at the very edge, because that's going to make it really easy to see which one is smaller, which one is bigger, and to do my comparisons. Okay. A lot of times when you ask students which fraction is larger, 1/2 or 1/4, they will, without hesitating, tell you 1/4 is bigger because 4 is bigger than 2. However, when it comes to reasoning about fractions, what we have to understand is the bigger the denominator, the number in the bottom, the smaller the piece. Because what that denominator is it tells you how many pieces have we broken this whole thing into. And the more pieces we get, the bigger that number gets, the smaller the piece is. So for this one, the largest fraction is going to be 1/2. The smallest fraction is going to be 1/4. It only goes to here. 1/3 is bigger than a fourth, but 1/2 is bigger than them all because it goes all the way to the middle there, and the others don't reach that point. Now let's look at problem 2. And before we get to problem 2, I would like to show you a tool that is very useful really for a lot of the topics we cover, but especially in fractions and comparing fractions. And that is here, this website. It's called Braining Camp. I put the login information on the newsletter, and I will keep it there for as long as I can. Braining Camp provides a lot of virtual manipulatives. There are tons of great math manipulatives, but very few people have those in their home. I mean, why would you? That would be ridiculous almost. So this kind of allows you to access some of the manipulatives that we use in class, hands-on manipulatives, but you can practice with them at home on a computer. Braining Camp is not free. I pay for it every year because I like it so much, and with my subscription comes a student login. My student login is H Hornets, Hornets, so H Hornets, that means there's 2 H's at the front, and then the numeral 3. My password is just Hornets 2024. And this will be good. I think I last got my subscription middle-ish of August. So this login, if you write it down somewhere, will work even through about the middle of August. So if you're doing things even in the summer, reviewing things, that should work for you, no problem. After that, it won't work anymore. I'm sorry. That's terrible. When you get to this, you log in. Here's the screen you're going to see. Today, what we're going to be using are going to be the fraction tiles. That's on the second row, third from the left. It says fraction tiles, not fraction circles. Honestly, when kids are first learning fractions, tiles are much easier to use if that's an option. They're easier to see and understand. When you click on fraction tiles, you'll see to the left all of these great fractions, and you drag them out And I love building this little visual here. Oh. And you can compare the sizes of each other. And I love this picture because you can start to see if I have one whole, it's one long strip. If I have two parts, I have two big chunks that make up that one strip. Three. And as I keep going, as that denominator gets bigger, that number at the bottom, oh, I can't circle that. Can I circle that? As my denominator gets larger, my pieces get smaller. And that is the reasoning and the understanding that we're looking for in third grade. Now, can I just, oh, no, that should go there. Come here, you. When we get to these twelfths, they're really little. So even though 12 is a bigger number than 10, twelfths, the fractional unit, is actually smaller than tenths. And this is where this kind of comes in handy because you can pull this up, and when you're comparing fractions, you can pull those fractions out to compare. So now let's use this chart to go back and compare some of the fractions that we have on this assignment right here on problem 2. A says compare 1/8 to 1/10. Okay, we can go back here. We can find 1/8. Let's see if I can make this a little bit smaller. Oh, without messing it all up. 1/8 to 1/10. Well, I can see that 1/8 is a smidge bigger than 1/10. So on my assignment, I'm going to represent that with the greater than sign. For B, I need to represent 1/2 to 5/5. Can I make this? Oh, I want to zoom that down a little without messing the whole thing up. So I'm going to pull out 1/2, and now it says 5/5. So I'm going to put 1, 2, 3, 4, 5. And to get those to pop up like that, I'm just tapping on it with my finger, or maybe you could click on it with a mouse. Well, I'm looking now at 1/2 compared to 5/5, and I'm seeing they're the exact same size. They are equivalent to one another, and that's a word we're going to be introducing with this lesson. So let's go back to our assignment. We'll use the equal than sign. 1/2 is equal to 5/5. 1/2 is equivalent to 5/5. Lastly, we want to compare 1/7 to 1/6. So let's pull out 1/6. We don't have a 1/7. Well, here's 1/8. My suspicion is if I have a 1/7, it's going to fall about, oh, I need a pen, here. Therefore, 1/7 would be smaller than 1/6. So we're going to use that less than sign. Unfortunately, I wish I could say the students would always have access to these manipulatives. However, when it comes to that STAR test at the end of the year, not all students will have access to manipulatives, and they will not be able to get onto Braining Camp. The state will have that computer locked down. I mean, super locked down. So I have kids practice drawing models to compare. Now, what I don't like about the problems that they were given here is that they're really close to one another, and it is really hard to see the difference when you're drawing by hand and you can't divide these sections out perfectly. But I'll kind of try to illustrate here what I mean. When we need to draw models to compare, the first thing we have to start with are models that are congruent, and that is an important word that will show up on assignments and tests. Congruent means same size, same shape, and we use the word congruent for our shapes and for our fractions in third grade. So here I have two shapes that are as congruent as I can humanly make them. Are you going to find a couple little flaws? Yes, but we're going to use our imagination now that I've done this perfectly. Let me represent, let's say 1/3 to 4/5. The first thing I'm going to do is on this first model, I'm going to divide that into thirds. To divide into thirds, I need 3 sections. 1/3, 1/3, and 1/3. The second bar I'm going to divide into fifths. Okay, let me go ahead and label each of these with the unit value, which is 1/5. And now I'm going to go ahead and lightly shade. The first one says I'm going to shade 1/3, and the second one says I'm going to shade 4/5. There's 1, 2, 3, 4/5. When I do that, that gives me the ability to look at and compare and see which one is greater. And the fraction that is greater here is 4/5. It's greater because it covers more space. It has a greater area. Now, if you see an assignment where what you're comparing is not congruent, say you're comparing that rectangle to that rectangle, you cannot do that, at least not in 3rd grade. If your shapes are not the same shape, you cannot compare that, at least not in 3rd grade. Your shapes to be compared have to be congruent, same size, same shape. Okay, I hope this helps somewhat on comparing fractions. It's important to practice drawing the models for those times that we don't have manipulatives, but I would also encourage you when you can to get onto Braining Camp, use those manipulatives when possible. The last thing I want to show you about them and how I like to actually use these fraction bars in class is I tend to take off, or I buy the fraction bars that are blank, the ones that do not have labels on them, because kids will start to rely on the labels too much. So if you can, down here, let me draw an arrow to where you're going to find it. You'll see this blank button. If you will click that, it will take labels off. If you're not comfortable with that or your child is really struggling, right here where it says 1/2 at the front here, you can click that and it's going to provide the support of the fractions labeled for you. Another thing that I would just like to point out is when your child goes to 4th grade, you may want to look into getting Braining Camp because they'll start learning decimals. Decimals are really just fractions, and you can click this decimals button over here where beside 1/2 fractions and start to compare decimals in this way and get a nice visual for that. And percents also, although percents, I don't think that happens. I'm trying to remember, 5th grade, 6th grade, one of those grades. Either way, I love the Braining Camp tool. It will be available to you with my login information through about the middle of August. After that, sorry, you're kind of on your own on that one, but it is a wonderful tool, so at least use it now if you can. If you have any questions, please feel free to reach out. I'll be happy to help however I can.